Welcome to the Deep Dive, where we cut through the noise to get you well-informed on the topics that truly matter. Have you ever been deep in thought, coding away, and suddenly your laptop fan starts screaming like it's about to take off?
Or your battery just dies at the absolute worst moment.
Exactly. Or maybe you're just tired of that little voice in the back of your head thinking, if this machine vanished, how many days of setup would just evaporate?
Yeah, that's a common anxiety, definitely.
Well, today we're diving deep into remote development. And we're not just talking about the basic idea of working from somewhere else. We want to explore how you can genuinely master this approach, making it efficient, secure, and, scalable. We've got some great insights lined up, pulling heavily from a really solid piece on the JetBrains blog, 10 remote development best practices. Our mission today, to give you a shortcut, basically, a way to understand what really makes remote development work well, moving past just working from home to something truly optimized.
It's such a powerful idea, isn't it? This concept of spinning up your whole development environment somewhere else, totally untethered from your local machine. It sounds, well, almost deceptively simple on the surface.
Deceptively is the key word there, I think.
Right, because what we're finding, what the industry is seeing, is that this simplicity can hide a lot of potential pitfalls, issues that teams and individual developers often only stumble upon way too late. It's not just about getting remote access. It's about making sure that access is effective, consistent, reliable, and secure, especially when you start thinking about team scale.
Okay, let's unpack that. So at its core, remote development. Pretty much what it sounds like, right? Your dev environment, the tools, the code, the runtime, it lives on a powerful server somewhere else, not on your laptop. You're just interacting with it.
Exactly. Your local machine becomes more of a thin client.
And the benefits seem pretty immediate and compelling. First off, you free up huge amounts of local resources.
Yeah.
Your laptop can actually stay quiet and cool.
Which is always nice.
Definitely. And maybe more importantly, there's that genuine peace of mind. If your laptop gets lost, stolen, breaks, your actual work environment, all that configuration, your code, it's safe somewhere else. You're not panicking about losing days of work or rebuilding a complex setup from scratch.
Those benefits are massive, no question. For individual developers, it's quality of life. For IT departments, it's manageability and security. But, and this is the crucial but, the real challenge often kicks in when teams try to implement this seriously, at scale. What we often see is that a sort of naive approach. It frequently leads to flaky setups, environments that drift apart, and just a general lack of visibility. You don't know what's going on. And it can end up being more frustrating than productive if you don't build it on solid foundations, on these best practices right from the start.
And that frustration, it often starts with the how. How are you actually connecting? So let's tackle a big one, a major pitfall. If you're still doing remote development by streaming your entire desktop, using things like RDP, VNC, maybe older VDS solutions, you might actually be shooting yourself in the foot, productivity-wise.
Oh, absolutely.
The source material we looked at had this brilliant analogy. It called it like lugging a cinema projector over SSH. You picture that?
Yeah, that's pretty vivid and accurate.
Think about what's happening technically.
Yeah.
Every single keystroke you make, every tiny mouse movement, it forces the remote machine to redraw huge chunks of pixels and then stream that video back to you. Your remote IDE feels laggy, unresponsive. It just doesn't feel local.
It feels sluggish.
Totally. And the second your internet connection hiccups, even for a moment, poof, everything can just freeze. You're left staring at a static image, wondering if that last change actually saved.
It's fundamentally inefficient. And it raises a really important question for anyone still relying on those methods. Why are we moving entire video frames across the network?
Yeah.
Instead of just moving the essential information, modern remote protocols, the good ones, they work completely differently. They only send basically keystrokes and UI deltas.
Okay, UI deltas sounds a bit technical. What does that mean in practice?
Think of it like this. Instead of sending you a full movie of your screen changing, it just sends tiny messages about what changed. Did you type the letter A? Okay, send A. Did a button highlight? Send that tiny update. Not the whole screen redraw.
Okay, so it's much less data.
Vastly less data. It makes the interaction incredibly lightweight and fast. Latency just plummets.
And the IDE feels snappy again, like it's running right here.
Exactly. Snappy, responsive. It's a critical difference. It makes the whole experience feel seamless, not like you're fighting the connection. This is like foundational for a good remote dev experience.
That's a huge improvement, and it leads perfectly into our first best practice from the JetBrains list. Staying online, even when you technically aren't. How many times have we all used, oh, the Wi-Fi is flaky, as an excuse for lost work or just getting completely derailed?
Guilty. We've all been there.
But with modern remote development clients, that shouldn't really be an excuse anymore. A proper client handles network interruptions gracefully. It buffers your edits locally while you're disconnected.
Right.
It shows you a clear reconnecting status, but it doesn't lock you out. Then, the moment the connection is back, it syncs your changes seamlessly.
It builds resilience right into the workflow.
Exactly.
And the key thing here is the seamlessness for the developer. Your code analysis, your linting, inspections, even breakpoints, they all just pick up where they left off. You don't lose your mental context. Your work doesn't vanish. That continuity is massive for keeping your flow state and just trusting the system.
Absolutely. Okay, so that's the individual experience. But let's zoom out now to the team, the enterprise. Running one remote VM or maybe a container, fine for a solo dev, maybe a quick demo.
Sure, easy enough to manage.
But what about 10 teams? A dozen different projects, hundreds of developers, each needing slightly different setups for different tasks. Trying to manage all that with manual scripts, SSHing into boxes, it just completely falls apart, doesn't it?
It crumbles fast. It becomes unmanageable chaos.
And this is precisely where the need for proper enterprise-grade orchestration for what are called cloud development environments, or CDEs, comes in.
Yeah, connecting this to the bigger picture, this is the point where things like scalability, consistency across the team, and just basic manageability, they stop being nice-to-haves. They become absolutely critical, non-negotiable, really, for any team that's growing or trying to maintain velocity.
Right. Without that orchestration layer, you're not just causing headaches. You're basically building a system that's designed to be brittle and inconsistent.
Which ultimately just slows everyone down, massively.
And the great thing about CDE orchestration is how it directly tackles those really common, frustrating pain points. The sources we looked at break these down nicely. Let's touch on a few key ones.
Okay.
First, resource scaling. Instead of having fixed, static setups that are either constantly underpowered or wastefully over-provisioned, CDE orchestrators let you do auto-scaling, auto-stopping when idle, creating snapshots. You use exactly what you need, only when you need it. Much more efficient.
Saves costs, saves resources. Big win.
Then there's the classic environment drift that, well, it works on my machine problem.
Ugh, yes. The bane of many teams.
CDEs tackle this using version-controlled templates and pre-built, standardized container images. Everyone gets the exact same environment every single time. Consistency.
Huge for reducing bugs and debugging time.
Next up, provisioning. Forget developers spending half a day installing tools and configuring settings.
Yeah, that's a massive time sink.
CDEs provide pre-warmed environments with tool chains, dependencies, secrets securely injected, plugins, everything ready to go. Developers can be productive almost instantly.
Which is the goal, right? Get coding faster.
Add security. This is huge. Instead of relying on potentially risky open SSH ports,
Which is a big attack surface.
you move to things like zero trust network access, secure relays, jump servers, maybe even air-gapped setups for highly sensitive work.
Yeah.
It's a fundamentally more secure posture.
Baked in security, not an afterthought.
And finally, visibility. Moving away from these dark, unmonitored environments where you have no idea what's happening.
Or how much they're costing.
Right. CDEs give you dashboards showing usage, system health, failure rates, real data to actually optimize performance and cost. Honestly, if you're at any kind of scale and you're not automating and orchestrating this stuff, you're consciously choosing to put your team at a disadvantage.
It really is a complete paradigm shift in managing development infrastructure. Like you said, the orchestrator handles everything: provisioning, tooling, secrets, health checks, cleanup. It ensures that consistency and efficiency, preventing those unique, impossible to reproduce snowflake environments that used to plague us.
Exactly. And the good news is you don't have to build this entire complex system yourself.
Thankfully.
Many companies have already invested heavily in solving these problems. So the smart move is often to borrow, don't reinvent, learn from the leaders. The source material points out several key players in this space. For example, you've got GitHub Codespaces. It uses that devcontainer.json standard to define environments, all running on GitHub's infrastructure. Pretty slick integration if you're already on GitHub.
Very popular, yeah.
Then there's Gitpod. They use a .gitpod.eml file for configuration, really focusing on providing consistent ephemeral environments for every branch or task.
Also very strong on the ephemeral side.
Coder is another interesting one. They focus more on self-hosted solutions running on your infrastructure. And they're putting a lot of emphasis on integrating developers with AI coding agents within those environments.
Right, bringing the AI into the CDE.
And of course, there's CodeCanvas from JetBrains, the authors of one of our main sources. They describe it as highly scalable Kubernetes-based environments designed to run on major cloud providers like AWS EKS, Azure AKS, Google GKE, or even on your own bare metal servers if needed, really targeting those larger distributed teams.
And looking at these established platforms, it really raises an important question for any organization thinking, hey, maybe we should build our own CDE platform.
Right. What are you potentially missing?
Exactly. What complex problems around networking, security, scaling, IDE integration, lifecycle management, what have these platforms already solved that you might underestimate? It's often much harder than it looks.
That's a super critical point. And it connects nicely to another best practice, understanding the difference between simple task automation and true workflow orchestration.
Ah, yes. This is key.
Like spinning up a virtual machine. That's just a task. You can script that pretty easily.
Terraform apply. Done.
Right. But combining that with building the right container image, securely injecting the right secrets for that specific user and task, running post-creation setup hooks, implementing proper health checks, and then automatically cleaning everything up afterwards. That's orchestration.
It's about connecting all those disparate steps into a single, cohesive, automated, and intelligent flow, not just running standalone scripts.
If you're still just, cobbling together Docker run commands and a bunch of shell scripts.
You're essentially reinventing a less robust version of what these CDE platforms already do extremely well. They're built to handle that complexity gracefully.
They abstract away all that tedious, error-prone manual work.
Which frees up developers to actually, develop features instead of wrestling with infrastructure scripts all day.
Okay, this leads us to something I think is becoming almost mandatory for modern, efficient development. The embrace of short-lived ephemeral environments.
Yes, this is a game changer.
We've all felt the pain of the traditional long-living dev environment, right? You cram everything for multiple projects or features into one VM or container.
And then what happens?
You waste so much time. Switching branches means complex rebuilds, resolving conflicting dependencies. You're just stuck twiddling your thumbs. It's incredibly inefficient.
And prone to weird state issues.
Totally. But the modern approach flips this on its head. When spinning up a new environment takes seconds, not hours.
They become disposable, like tissues.
Exactly. You create a fresh, clean, perfectly configured environment for every single task. A new feature, new environment, code review, new environment, bug fix, new environment, and when you're done, you just toss it away. No leftover cruft, no conflicts, no drift.
And the magic that makes this practical is the underlying tech. Things like warm-up snapshots and pre-booted standby pools. It means a new environment isn't usually built entirely from scratch each time. It's often cloned from a pre-warmed, ready-to-go template.
So the cold start problem mostly disappears.
It's massively reduced, yes, which makes creating these ephemeral environments incredibly fast. And the benefits are huge. Guaranteed consistency, dramatically improved security because the attack surface is constantly reset, and more predictable costs since resources are only active when needed and shut down automatically.
Speed, security, cost. Pretty compelling trifecta.
Win, win, win.
All right, let's shift gears slightly to something that absolutely cannot be compromised. Security and compliance.
Non-negotiable, especially here.
Convenience is great, but it cannot come at the expense of security. Getting crowned because your remote dev setup was weak? That's a nightmare scenario. Protecting your code, your IP, your customer data is paramount.
Absolutely critical. Development environments are juicy targets for attackers.
So the sources emphasize practices that go way beyond just having a firewall. First up, zero trust.
The new standard, really.
It's a fundamental shift in mindset.
Yeah.
Instead of trusting things just because they're inside your network perimeter.
There's nothing. Verify everything.
Exactly. Authenticate and authorize every single connection. Every user, every device, every IDE connecting to a remote environment every single time. No implicit trust.
It compartmentalizes risk. Even if one part is compromised, the attacker can't easily move laterally, like having security at every internal door, not just the front gate.
Then there's strong network isolation, using things like per-cluster relays or secure jump servers. Critically, no direct SSH access exposed to the public internet.
Minimizing that attack surface again.
Even things like restricting clipboard actions to prevent accidental or malicious data leakage.
Smart. Data exfiltration is a real risk.
And finally, robust policy enforcement. aligning everything with established security benchmarks and your own company policies. Recognizing these dev environments need guarding just as much as production.
And trying to bolt these security measures onto a manual setup for every single developer, it's practically impossible to do consistently and correctly.
Right, which is another huge advantage of CDE orchestrators.
Yeah, they bake these security controls right into the platform. Security becomes the default, the easy path, not a checklist nightmare developers have to struggle with.
Essential for regulated industries, but really for any company serious about protecting its assets.
Absolutely.
Okay, so we have this sophisticated orchestration, built-in security. How do we know if it's actually performing well, if it's efficient?
Data. You need metrics.
Exactly. Metrics that actually matter for optimization, those dashboards we mentioned. They aren't just pretty pictures. They are your essential feedback loop.
They drive improvement. You can't optimize what you can't measure.
So what are the crucial things to track? The sources highlight several key ones, like startup latency. How long does it actually take from requesting an environment to being able to run your first build or have the IDE finish indexing? Milliseconds matter here for developer happiness.
Big impact on perceived performance, yeah.
Then, resource utilization. You need granular data. How much CPU, memory, disk I/O is each workspace actually consuming? Are you over or under provisioned?
Critical for cost optimization and capacity planning.
Idle time is another big one. How long are environments sitting unused? This data is essential for tuning those auto shutdown policies effectively.
Stop paying for resources nobody is using.
And of course, failure rates. Are backends crashing? Are developers experiencing frequent disconnections or reconnection issues? You need to monitor the health and stability.
Identifying problems before they become widespread frustration.
Using tools like Prometheus and Grafana, maybe Dynatrace, or the cloud provider's native monitoring tools.
Right, standard observability stack.
Lets you connect the dots.
Yeah.
You can correlate developer efficiency metrics directly with the health and cost of your underlying infrastructure.
It creates that virtuous cycle of data-driven improvement. Find bottlenecks, fix them, measure again. Without these metrics, you're just guessing. You're flying blind.
Totally. Okay, one last best practice, and this one is looking squarely at the immediate future, which is basically already here. AI agent support.
Ah, yes. The elephants in the room.
It's not optional anymore, is it? Your CDE orchestration platform has to treat AI agents, think coding assistants like Copilot, or automated testing agents, maybe AI-driven code reviewers as first-class citizens.
Not just an afterthought tacked on. They need to integrate smoothly.
Which means the platform needs clean, well-defined APIs for these agents to interact with. It needs bulletproof permission systems so agents only access exactly what they're supposed to.
Least privilege principle applied to AI.
And tight resource controls so an experimental AI doesn't accidentally spin up 1,000 high CPU instances and bankrupt you overnight.
Haha, yeah, that's a legitimate concern. You need guardrails.
Integrating AI effectively requires a CDE platform that was designed with them in mind, or at least thoughtfully adapted.
And the really fascinating, maybe slightly scary thing here is how quickly neglecting this aspect will leave an organization behind. AI integration and development workflows isn't just a nice-to-have advantage anymore. It's rapidly becoming baseline. It's table stakes.
Non-negotiable, as you said earlier.
Pretty much. Having an orchestration layer that seamlessly supports these AI agents isn't a luxury. It's becoming a necessity to stay competitive and keep your developers productive in this new landscape.
Wow, okay. So let's try to pull this all together. We've covered a lot of ground in this deep dive. The core message seems pretty clear.
Yeah.
If you're still stuck using older methods like RDP or VDI for pixel streaming.
Still loving that cinema projector.
Exactly.
Yeah.
Or if you're relying on manual SSH hacks and managing individual one-off VMs for remote dev.
You are, whether you realize it or not, actively choosing friction. You're choosing inefficiency over productivity.
You're leaving performance and security on the table.
The path forward, the best practice, really involves embracing several key things. Protocol-smart remote dev clients that use those efficient UI deltas, sophisticated orchestration for short-lived, ephemeral environments, robust, baked-in zero-trust security, and meaningful, actionable metrics to drive continuous improvement. And these patterns, these principles, they really aren't optional anymore if you genuinely care about scaling your development efforts, ensuring enterprise-grade security, and maximizing your developer velocity. That holds true no matter which specific platform you might choose, whether it's CodeCanvas, Coder, Codespaces, Gitpod, AWS Cloud9, or something else. The underlying concepts are what matter.
Ignoring them means you're missing out on some really significant gains in productivity, security, and just overall developer happiness.
Absolutely.
Okay, that's a powerful summary. And it leaves us with a final, maybe provocative thought for you, our listener, to chew on. We spent a lot of time talking about lugging a cinema projector when it comes to remote desktop streaming versus modern protocols. So the question is, how often might you be doing the equivalent of that, lugging a heavy, inefficient projector in other parts of your work, beyond just remote development?
Interesting question. Where else are we inefficient?
Where else are you sending massive, clunky data streams or following outdated manual processes when there might be a much more elegant, lightweight code diff equivalent available? What amazing potential for optimization, for speed, for creativity are you maybe missing out on simply because you're sticking to the old ways, the way it's always been done?
It's worth reflecting on, are there other projectors in your workflow?
Definitely something to think about. Take a moment, maybe after this, to consider your own environment, your own workflows, and see if there's an opportunity to take a fresh look, a critical look, at how you're approaching things. Thank you for joining us on the Deep Dive.